Payal from ICFI Business School, Bangalore, presenting you my business intelligence and analytics topic today. So, in today's data driven business environment, organizations increasingly rely on business intelligence and analytics to support informed decision making. Business intelligence focuses on collecting, processing, and visualization your historical and current data, while analytics extends this capability by making statistical and machine learning techniques to predict future outcomes. This project of mine has been undertaken as a part of Business Intelligence and Analytics course and is designed to demonstrate the practical and application of both predictive analytics and descriptive analytics. The project has been divided into two major parts. The first part, which focuses on supervised learning technique, and I have considered the logistic regression using Python, and the second part focuses on Power BI dashboard, which presents business data in visually intuitive and decision oriented manner. The objectives of the study is mainly to understand the role of business intelligence and analytics in modern decision making, apply supervised learning techniques for predictive analytics, and analyze and interpret model outputs using appropriate performance matrices to design and develop an interactive Power BI dashboard for descriptive analytics, and to integrate both predictive and descriptive analytics for holistic business interpretation. The scope of the study is application of logistic regression for binary classification problems using structured data, analysis of results based on standard evaluation matrices such as accuracy, precision, recall, and ROC-AUC curve, and then development of the Power BI dashboard and interpretation of insights from business intelligence perspective. I have used Python Anaconda for the logistic regression supervised technique. Let's have a look at it. So this is the Anaconda Jupyter notebook where I have performed the logistic regression of the hard data set. Firstly, we have to load down all the libraries: pandas, numpy, matplotlib, seaborn, and standard scalar for standardization of the data, matrices which is necessary for logistic regression, that is accuracy score, precision, F1 score, classification report, confusion matrix, ROC AUC curve, and of course model selection, import the train test split. We start off by reading the data, then looking at the head and tail and the data cleaning part, the shape of the data. This is one of the major part of data cleaning process where we check for null values, and wherever necessary we impute the data. For categorical columns, we use mode for the imputation of data, whereas for numerical columns we can use median as well as mean, but I have used median for the imputation of numerical columns for this data set, and we have imputed all the non null values, and after the imputation we see that there are no missing values in the columns. Then we started off by defining our x and y, that is our predictive and response variable. Then training and testing of the data takes place. Standardization of the data, converting the data, the numerical columns to z-score, normal distribution. Then we convert back the arrays to the data frames, and we look for the x train shape, x test shape, y train shape, and y test shape. Then we fit the model using x train and y train, and we try to plot the confusion matrix, which consists of the actual y's and predicted y's in it, which has true positive, true negative, false positive, and false negative. Then we try plotting the confusion matrix using a heat map. Calculating the matrices is very important, and so we start by calculating these five important metrics of logistic regression, that is accuracy score, precision, recall, F1 score, ROC AUC score for the Y test and Y predict probability data. We also get the confusion matrix, classification matrix, and the matrices. And one of the major curve of the logistic regression is the ROC AUC curve. We try plotting it and we see that AUC is 0.7. Let's have a look at the insight from the logistic model. We have seen that the true negatives from confusion matrix are 710, false positive were 9, false negative were 120, true positive were 9, and the AUC score we received was 0.69, which was approximately 0.7. So insight from the model are this shows high number of true negatives, which indicates the very good at correctly identifying the negative class. However, it struggles significantly with positive class, as evidenced by high number of false negative, that is 120, compared to the true positive, which is quite less in number. And the AUC score of approximately 0.7 suggests that the model has a fair ability to distinguish between the positive and negative classes, and it actually performs better than random classifier, but still have some considerable room for improvement. So the logistic regression model currently has identified 710 true negatives, which is correct, but not only 9 true positives. The model produced 9 false positive and 120 false negative, which indicates that predict the tendency to predict negative class and struggling to correctly identify the positive class. And the AUC score for receiver operating characteristic curve was approximately 0.69 to 0.7. Moving on to the second part of the data, that is the dashboard presentation. I have chosen a hotel dashboard. Come, let's have a look at it. So here's the dashboard. Control clicking on price and availability leads me to the second page. Similarly, host performance leads me to the third page. The fourth page, review and guest satisfaction, and the fifth is property type and room. Let's move on to the geography. So we see here there are two slicers. One is the host location and the neighborhood. So suppose I click on Australia in the host location. I see the map's location changes accordingly. And if I select a neighborhood from here, the second slicer, I can see the necessary changes in the map. Moving on to the price and availability. So we can see that there are a variety of price by property type, whether it's a rental, a home, a hostel, or a resort, a service, a guest, a villa, which is represented in this donut chart. We see this gauze of price, and where we can see that the target value, the actual minimum value, the maximum value, target value is actually represented. Then we see that the sum of accommodates are 579 and the sum of availability 30 is around 3k, and the room type, the slicer, where we can choose either entire room, the hotel room, private room, or shared room, and accordingly we can see changes happening in the dashboard based on the price as well. Let's move on to the host performance. So verification That was either by email, email, phone and work email, or just the phone number. And we can see the varying responses and the response time, that is whether it was within a day that they received the responses, or not applicable, a few days or more. By clicking the slicer, we can see a variety of changes happening in the dashboard. This is a host listing which has a sum of calculated homes of host listing counts, a sum of calculated count of entire homes, sum of calculated host listing, that is only for the private rooms, and the fourth one, the sum of listing count shared of the shared rooms. Next, let's move on to the review and guest lecture satisfaction. The review score here is approx 67.19K. Cleanliness reviews were 66.08, and we can see the host listing in the pie chart, where the sum of host listing counted share rooms. And by clicking on the first review date on any date, we see the changes happening. Similarly, in the last review date, we see the changes happening and the numbers changing. Next, let's move on to the property type. So the property type is boat, bus, dome, entire condo, entire home. And depending on the property, we see that the prices change and the response also. The host responses also change based on the location, and it totally depends on the property type. And the room type also changes. So, coming to the integrated business interpretation, logistic regression model provides predictive insights, while the Power BI dashboard offers the descriptive insights. A few recommendation is using predictive analysis for early risk identification and planning, focuses on high performing locations and property types, then improve host responsiveness to enhance customer satisfaction. Concluding my project by saying that this successfully demonstrates the practical application of business intelligence analytics concepts by integrating predictive analytics through logistic regression and using Power BI dashboard. So this supports in proactive decision making. Interactive dashboards enables an effective visualization, monitoring, and interpretation of the business performance. Overall, combined use of machine learning and AI and business intelligence tools highlights the importance of transforming raw data into meaningful insights that support strategic, tactical, and operational decisions. The methodologies and insights presented in this project demonstrate the growing importance of analytics in modern organizations and provide a strong foundation for future application in real world of business. Thank you so much.